So today we're going over 4.1. I left something in 4.1. 4.1 is exponential function. So last time I started for this section, but I left something here in this section. I'm going to go over these things today. First of all, I defined the exponential function as a function. So exponential function of base A is function of the form f of x equal a to the x. Okay, so this is the exponential function. And last time also I talked about the graphs of exponential function. I said the graph of exponential it's going to be like something like this. So here is the Cartesian plane. So the graph for f of x here, f of x equal a x such that a here is greater than 0, greater than 1, and here f of x equal ax if a between 0 and 1. So if this a is greater than 1, the graph gonna be something like this. Here is a, here is 1, be like this. Okay, this is f of x. This point is 1. But if a between 0 and 1, the graph will be like reflected around the y-axis. So the graph will be something like this. Okay, so this is the function. Let me change here, instead of f of x, I'll make it like g of x. So here g of x this here is g of x. Okay, this point is 1. X-axis, x-axis, y-axis. Here's y. Okay. Second things, we have to know the domains and the range. So the domain, what is the domain for the both function, or for the function f of x or g of x? What is the domain? What's the x value are used for the function? What is the domain for the exponential function? Or you can ask yourself, what's the x value are used for the Cartesian plane? Real numbers, exactly. Knowing he said the real numbers. Like I can all the real numbers from, like Angel, he said also, from minus infinity to infinity, all these numbers are used for the domain. So the domain can be as all these things, all the x values are used. So the domain will be the real numbers. Also the same things here. So this is the domain. The domain is the real numbers. What is the range? What is the range? What's the y value are used for the exponential function? What's the y values are used? It shows from Martin, this is for the domain. Yes, this is true. But the y values is starting from the 0
to infinity.
To infinity. The 0 is not inside the range. It does not include it. So open parentheses from 0 to infinity. Okay, is it clear? So the range here will be like from 0 to infinity, like this. But as the 0 is not included, so I'll make it like a little bit like I'm not going to include the zeros. Will be close to the 0, but does not including the 0. Same things for this one. So I can set here, this is the range, range, and the pink one is the domain. What is the horizontal line? What is the horizontal asymptote? What is the line? What is the horizontal asymptote?
The x-axis.
The x-axis, exactly. So how can I define the x-axis? What is the equation, or what's the formula?
Y equals 0.
Y equals 0, yes. So I can set here the domain for all exponential function are from SR, real numbers. Or I can set from minus infinity to infinity, like this. The range is from 0 to infinity, like this. And the horizontal line, horizontal asymptote, it's the x-axis. I can define it as y equal 0. Okay. Another things here, it's look like the exponential functions look like one-to-one function. How I know? By using the horizontal line test. Look, here is my horizontal line. Like I said before in previous sections, the line intersects the curve at only one point. This means the function is one-to-one. The same things for this one. The function intersects the horizontal line at only one point. This means the exponential function is one-to-one function. Here I can set the exponential function is one-to-one function. What does that mean? The function is one-to-one. What is that including when I hear the function is one-to-one? Anyone? What is the meaning of the exponential function is 1 to 1? What is that? I can like know. How did you find the horizontal asymptote? The horizontal asymptote is y equals 0, the x-axis. Why? Because the curve will be like close to the x-axis, but will not touch it at all. The red, you see the red curve will be like so close to the curve, to the line, but will not touch the x-axis at all. So this is mean the x-axis will be like my horizontal asymptote. The x-axis has as a line is, the equation for the line is y equals 0. The equation for the x-axis is y equals 0. Another things, the exponential function is 1 to 1 function. What does that mean? If you told me what does that mean, you can. What does that mean? The function is 1 to 1. Means the function has inverse. If the function is 1 to 1, this means it has inverse. So the function has an inverse. So if the function is 1 to 1, this means the function has inverse. The inverse for this function, I'm going to go over this one in 4.3, section 4.3. Okay, so now let me give you an example. Find the exponential function here. So let me do this one. Find the exponential function f of x equal a to the x whose graph is given like this. So for the first one, here. So here the graph looks like this. And this graph passing the point here, there's a point here, is 2 and 25. And there is another like curve here. This curve passing this point here is 3, 1/8. So I'm going to do this one, A, and B is exercise for you. 5. Yes, Angel, this is true. Okay. So the question is, find the function f of x. So let me do the first one. I explain how I do it. So the function f of x equal f of x so the function is f of x equal a to the x. I need to find this function. I need to find the value for a. This is the question is. I need to find the value for a. So for the first one is give me like exponential function. This is look like exponential function. This exponential function passing this point, 2 and 25. From this point, I can get like means f of 2 equal 25. From this point, I can obtain this things. F of 2 is 25. Now I go here to this function. So f of 2 is equal 25. Now I do plugging this 2 inside the original function here. And after I plug it, so I get here f of 2 equal a to the 2. Plug the 2, a to the 2. A to the 2 is equal the same as f of 2 equal 25. So this is equal 25 here. Okay? So now this is mean a square equal 25. A square equal 25. And the 25 is equal 5 to the 2. So this is mean a equal 5. And now I can find the function. So f of x, instead of a, I put 5 from here, is equal 5 to the x. So this is my function. So let me do it again, explain it again. My question is f of x equal a to the x. I need to find this function. It's given the curve passing this point, 2 and 25. This is mean f of 2 is equal 25. Now I plug the 2 inside the original function here. I get f of 2 equal a to the 2. And f of 2 is the same as 25. So a to the 2 is equal 25. Now I need to find a, the value for a. Since a square equal 25 and 25 is equal 5 to the 2, this is mean the exponent here 2 and 2 are equal. This is mean the base must be equal. So a equal 5. So from now, from these things, I can find the equation of the function. I mean, like I can find the function. So f of x equal 5 to the x. Same idea here. I'm not going to do it all of the question. So, but here I can say f of 3 is equal 1 over 8. And my function I'm looking for f of x equal a to the x. I plug inside x3. So I get f of 3 equal a to the 3. Now f of 3 equal a to the 3, and this is equal 1 to the 8. And 1 to the 8 is the same as 1 to 2 and everything to the 3. So a here equal 1/2. Why? Because the power is the same. So a equal 1 to the half. Now you can continue and you find the function. Okay? Did you mean a to the x? Yes, I need to find a to the x. Here, I need to find the function. I need to find these things. This one. I need to find this one by finding a. If I find a, so I find the function. Okay, any question? Any question? Is it clear? Okay, now let's go to the graph, how we can graph the exponential function. Is it 1/2, 1 to the 2? No, hold on. It's not the same. F of 3 is 1/8. F of x equal a to the x. Now plug the 3 inside this function. So I get f of 3 equal a to the 3. And f of 3 already it's given. It's 1 to the 8. And 1 to the 8, 1/8 is the same as 1/2, everything to the power 3. Why? Because the power 3 we distribute inside the parentheses. I get 1 to the 3 and 2 to the 3. 2 to the 3 is 8. 2 times 2 times 2. Okay, so here the power is the same, 3 and 3. This is mean the base a must equal 1/2. That's why a equal 1/2. Now after that you can continue and you find the function of x equal 1/2 to the x. So here I can say f of x equal 1/2 to the x. Okay. Now we're going to go over the graphs. Example, transformation. So by using the graph, of f of x equal 2 to the x, sketch the graphs of each of number 1 g of x equal 1 plus 2x, b h of x equal minus 2x, c d of x equal 2 to the minus 2x. Who will do the first one? G of x will have an asymptote at 1. This is true. Thank you, Angel. This is right. But how can I graph it, Angel? What does that mean, 1 plus 2x? Can you explain? So, okay, I'm do it. F of x equal to the 2 to the x. So the graph for this function is like this. This 2 to the x. The 2 is greater than 1. Like I said here, if the a is greater than 1, the graph will be look like this. So here the same things. F of x equal 2 to the x. 2 is greater than 1. So the graph will be something like that. The asymptote here, horizontal asymptote, is the x-axis, y equals 0. This is my original function, f of x equal 2 to the x. For the first one, they told me graph the g of x by using the transformation. What is the mean of 1 plus 2x? What does the mean 1 plus 2x? One plus 2x means I have to grab this function, original one, then I have to shift it 1 unit up. This is the review from 2.6. 1 plus 2x means we have to shift the original function 1 unit up. So the horizontal asymptote is y equals 0, this one, the x-axis. Now when I shift it up 1 unit, become y equal 1. So this is my horizontal line now. This is my horizontal asymptote. Become here. This is the first step. This is my horizontal asymptote. So this is my horizontal asymptote. The equation for the horizontal asymptote is y equal 1. So here, y equal 1. Why 1? Because at 1, the line intersect the x-axis, the y-axis. Now, every point here in the curve will go up 1 unit. This is go up 1 unit. This is everything goes up 1 unit, and this is my horizontal asymptote. So the graph will be something like this, like that, going up, this, going up like that. This point now is 2. And my horizontal asymptote is y equal 1. So this is g of x. Any question? So everything here goes up 1 unit. Anyone has a question? How the graph? Okay. Now for the second one, minus 2x. Who will do the second one? Who will do the second one? H of x. Who will do the second one? It's a flip across the x-axis. This is 100% true. This is true. So when the minus is outside the function, this is mean we have to reflect the function around the x-axis. So my original function is this. This is my original function here. Like that. This is the function 2x, f of x equal 2x, 2 to the x. So minus outside the function means we have to reflect this curve around the x-axis. So my mirror will be the x-axis. So this is my mirror. This is my x-axis. So everything will be reflected down. So this point will be like around here, and everything will be reflected like this. So the red one is the h of x. H of x equal minus 2 to the x. What is the horizontal asymptote? Is the same things, y equals 0. For the last one, who will do the last one? For the last one, we, like Chris, he said, we flip it around the y-axis. This is true. So the original curve like this. This is 2 to the x, f of x. Now we reflect everything around the y-axis. Why? Because the minus, it's inside the function. It's up. So the new graph will be reflected at around the y-axis like this. So the 0 keeps 0. Here, this point stay the same things, and everything like this. Okay, so this is the new one. It is d of x. This is d of x equal 2 to the minus x. Okay, any questions so far for the graphs? Anyone has a question? Anyone has a question? Okay, no questions. This is mean everything is clear. If you have a question, you can ask before I go to the next slide. No questions? Okay. So now, after we learn how to graph the exponential function, and so we finish from this section. So now let's go to the 4.2. 4.2 is a small section. Talk about the natural exponential function. The natural exponential function. So first things, we have to know the number e. The number e. The number e is like it's defined. This number is defined as is defined as 1 plus 1 over n to the n when n is become large number, as n is a large number. You don't have to memorize these things, but I'm going to explain how we can find the e from these things. So for example, if this is n, this is my n, this is for 1 plus 1 over n to everything n. Here, if I choose like number 1, if I choose like, for example, 2, 5, so when I plug the 1 inside this equation, I get 1 plus 1 over 1. This is mean 1 plus 1 over 1. This means 1 plus 1 equal 2 to the 1. So everything is equal to 0.0. Now for the 5 is 1 plus 1 over 5 to the 5. They give me value 2.488. And when I go like to the large number, for example, like number 1000, when I mean like million, 3, like big numbers. So the answer here will be like around 2.718. This is the value for E. So I can set here now, E is approximately like 2.718. This is what you have to know. The value for E is 2.78. How can I find it? When I plug like big number inside this expression, so I get the value 2.718. Just you have to know the value E is 2.718, okay? Yeah, it's a constant number. So E is 2.718. Here is the technique how they find the number E. They get this expression, they plug a big number, and is like bigger than 1 million. Like more and more big number, they give you like the number 2.718. This is the approximation number. It's not the same exact number, it's approximation. If you want the exact, here's like there is still some decimal here. E is irrational numbers, okay? The number E is irrational number. Now let's go to the important things. It's called the natural exponential function. The natural exponential function. So I said E is the number like around equal 2.71. And E is between two numbers. I can set between 2 because 2 is smaller than this number, and E also between 2 and 3. So E, the natural number, is between the number 2 and between the number 3. If I raise these things to the power 2 to the x, it's still smaller than E to the x, smaller than 3 to the x. This is mean E to the x has a graph as exponential function, and it's a graph between 2 to the x and 3 to the x. So now let me show you how we can graph E to the x. So the graph E to the x will be like this. I'm going to use different color here. So 2 to the x, 2 to the x is smaller than E to the x, smaller than, using different colors here, 3 the x, and I'm going to use this color for e to the x. No, it's not nice, right? So let me use the green one. So e2 to the x, I can graph it like this by using the blue color. So e to the x at 1 would be like this. So this is e to the x. 3 to the x will be like above this one, like around like that. Like that, exactly. Oh, like this. But for the blue will be like a little bit down, here more up, like this. Now for the green one will be between the red one and the blue one. So e to the x will be like this, around here. So the green go like this. Between the two curves. It's a little bit hard to graph it. Let me do the half and half. So it'll be like this, here up to here, the same things. So this is e to the x. Oh. Like this. So the green is e to the x, the blue is 2 to the x, and the red is 3 to the x. So this is the graph for the exponential function. Now example. So the example now, graph the function by using f of x equal e to the x graph g of x equal e to the x minus 1 and t of x equal e to the x minus 1. So I'm going to do the first one, and the second one is exercise. So for the first one, what does that mean? E of x minus 1 for the first one. What is the mean of minus 1 outside the function? Here, I get a question. Are all lines on the point 2? Here, this is the point 1. This is 1. It's not 2, 1. Knowing it. All this point is 1. It's not 2. For this one, e to the x minus 1, what does that mean? So this is mean I have to graph the original function, then I have to shift it 1 unit down because the minus is outside. So this is the original graph. This is f of x equal e to the x. This is 1. Now we have to shift everything 1 unit down. So this is my horizontal line asymptote, the x-axis. Now my horizontal asymptote will be like down 1 unit. Be like this. So here, like my horizontal asymptote. This is my horizontal asymptote for the new graph. So this is y equal minus 1. Now everything shifted down 1 unit, so this 1 becomes 0 here, and the curve will look like this. No, like that. So this is g of x. Who will do the second one? Or give me like the idea for the second one. So everything here shifting 1 unit down. Who will do the second one? Or tell me the idea for the second one. Give me the idea for the second one. E to the x minus 1. So the graph will be something like everything we shifted to the right 1 unit because the power has x minus 1. So this one is d of x equal e to the x minus 1. Any question? Anyone has a question? How to graph the exponential function? Okay, if no questions, this is what you have to know in this section. This is the only things you have to know in this section. How to graph the exponential function. What is the meaning of exponential function? And here everything we have to shift it to the right. Okay, now let's go to the 4.3. 4.3 is the logarithmic function. So we start this function, this chapter by exponential function. The second part is the natural function. Now logarithmic function. So exponential function, natural function, now logarithmic function. So first of all, as I said before, the exponential function here, the exponential function is one-to-one function. So this is mean the function has inverse. What is the inverse for the exponential function? Is the logarithmic function, the log. So the log is the inverse of the exponential function. So here I can say the inverse function of exponential function. So this is the inverse for the exponential function, the logarithm function. So I can define the logarithm function as logarithm function. So log function with base a is defined as log to the base a. So it's defined as logarithm log x to the base a equal y. This is exactly like a to the y equal x. This is the definition of the logarithm. Logarithm x to the base a equal y. This is mean a to the y equal x. A here is called base, y is called exponent. So this is exponential forms. Here is the logarithm forms. So as I said before, this is the inverse for the exponential function. So there is a relation between two of these functions. So let me give you example. Example here. Small example as a review for logarithm. Evaluate a logarithm for 1000 to the base 10 is equal, and B, logarithm 32 to the base 2 is equal. So for the first one, here how I can thinking for logarithm of 1000 to the base 10. So I ask myself, I make this everything equal x, okay? I ask myself, 10 to the which power they give me 1000? 10 to the which power they give me 1000? What is the value for x that make me x 10 to the x equal 1000? Here, if I want to think for the answer, I said 10 to the which power they give me 1000. What is the answer? If I raise the 10 to the 1, they give me 10, is not 1000. 10 to the 2, they give me 100, not 1000. 10 to the 3, they give me 1000. This is mean 3, the value x is equal 3. So this is equal 3. So the answer is 3. It's raising to the 3. Yes, Justin. So the answer is 3. Same things here. I put x and I ask myself, 2 to the which power they give me 32. 2 to the 1 give me 2 is not 32. 2 to the 2 they give me 4, not 32. And I keep continuing until 5. 2 to the 5 they give me 32. So the answer here is 5. So the answer here is 5. Any question? Here I can ask myself, 10 to the what power they give me 1000, and 2 to which power they give me 32. Anyone has a question? Okay, this is the evaluation for the logarithm function. Now let me give you properties for the logarithm function. So the properties for logarithm function says properties of logarithm. First property says the logarithm for the 1 for any base is equal always 0. Second one, logarithm for a to the base a is equal 1. Number 3, logarithm a to the x to the base a is equal x. Number 4, a to the logarithm x to the power to the base a is equal x. This is the properties for logarithm. Example, by using these properties, find a logarithm 5 to the 6 with base 5 is equal b logarithm 6 to the base 6 is equal c logarithm 1 to the base 7 is equal who will do the first one? Logarithm 5 to the power 6 with base a is, Angel, he said 6. This is true. Which property did you use here?
The third one.
Third one, yes. By using number 3. This. Who will do the second one? Log 6 with base 6. What is the answer? Using this properties, number 2. Log a to the base a is equal 1. Log 6 to the base 6 is 1. By using number 2. Third one. Kristen, this is true. C 0, right? This one, C, 0. Yes, this is true. Why? By using first one. Logarithm for 1 for any base always 0. By using 1. Any question? Okay, let's now go to the graph of logarithm function. Graph of log function. So as I know the graph for f of x equal a to the x, since the logarithm is the inverse function of the exponential function, and I know the graph for the exponential function from the first section of this chapter, and like before I said, to graph the inverse is by reflecting any function around the line y equal x. So this is my line. I have to reflect anything around this line. This is y equal x. If I reflect anything around this line, I can graph the inverse function, and my inverse function is the logarithm. So my exponential function, suppose my exponential function is f of x equal a to the x, which a is greater than 1. So the graph will be like this. Like I learned from section 1 of this chapter. This is the exponential function. F of x equal a to the x, and a is greater than 1. So I have to reflect all this point around this line, y equal x. If I reflect all this curve around this line, this is mean I can graph the logarithm function. You start at 1, exactly. So at 1, here is 1, and here is 0 and 1. The reflection for this point will be like around here. This point is 1 and 0. And all this point will be reflected, like this is my mirror, y equal x. Put a mirror, reflect everything around this. So the reflection for this point will be like around here. this point like around here, this point like around here, like this. And all these things around here, this point will be around here. So the graph will be something like that. So this is the graph for logarithm function. Log of x to the base a. This is, I call it g of x. This is g to the x. And again, this is my asymptotic, is a vertical line. This x equals 0. The equation of the line of the y-axis is x equals 0. So now again, my graph for the logarithm function is this graph, this curve, this one. I reflect all the point around the y equal x. So I get this curve. This curve has a vertical asymptote is x equals 0. Okay? So now I know how is the graph for the logarithm function. The graph for the logarithm function will be like this. So now the example, by using the graph of f of x equal logarithm of x at the base a, sketch each of the following. The first one is g of x equal minus logarithm. Here, instead of a, I'm going to use like number, like for example 2 or 3, whatever. Okay, use 3. So the base is 3. So the logarithm of x to the base 3, and number b, graph the function d of x equal logarithm of minus x, the minus is inside, to the base 3. Who will give me the idea for the first one? How can I graph the first one? The minus is outside. What does that mean? So first of all, the logarithm function here, I can graph it like this. First things this. This is my first step. So this is my logarithm function. This is f of x equal log x to the base 3. Angel, he said under the x-axis. So we reflect these things around the x-axis, like Angel, he said. So my mirror right now, it's the x-axis. So this is my mirror. We reflect all the point around this mirror. So my new graph is this reflected around itself, all this point like around here, like this point around here, this point around here, this point like around here. So the curve, the new curve, and this point, the same things, up, 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 and so the new curve will be something like this. This is the new curve. This is g of x equal minus log x to the base 3. So the red one is the graph for my first one. For the second one, it's the minus, it's inside the function. What does that mean? So first of all, we graph the original function. It's like that. This is f of x. What does that mean? The minus is inside the parentheses of the function. This is a review from last time. The minus is inside, this is mean. If it's inside, this means we have to reflect it around the y-axis. Yes, Angela, that's true. Thank you. So we reflect all the point around this mirror. So this is mean this point will be like around here. And this point like around here. This point here, here. So the new curve will be something like that. This is the function d of x. We reflect everything around this curve. Like around like this. Okay, any question? Any question for this example? Anyone has example? Any question? How to do the graph? Okay, if there is no questions, let's go right now to a new kind of equation for function. It's called the common logarithm function. So the common logarithm function. So what is the common logarithm function? Is the logarithm function to the base 10. If the logarithm function to the base 10, this is mean called the common logarithm function. So I can define it here as a logarithm to the base 10 defined by log x. We don't have to put the base here. So log x without the base means log x to the base 10. So we don't have to write it down. Okay? When you see something like that, log x means log x to the base 10. Example for like common logarithm function, something like that. Like log to the 10 and log to the 100. What is the value for log to the 10? 1, exactly. So log to the 10 is exactly like log to the 10 with the base 10. And by using the properties, log 10 to the base 10 is equal 1. So here log 10 to the base 10 is equal 1. For the second one, 2, exactly. So this is equal log 100 to the base 10. I can ask myself which power If I raise the 10, they give me 100. Like 10 to the which power? They give me 100. So the answer is 2. So the answer is 2. The last logarithm is called the natural logarithm. So what's the natural logarithm? I gave the common logarithm, now the natural logarithm. So the natural logarithm. So the natural logarithm is a logarithm to the base e. E is the exponential function here. This is e. This is the number t, 2.7, 2.718. So if the logarithm to this base, this is called the natural logarithm. So here is a logarithm to the base e and is denoted by ln. So when you see ln of x, this is mean logarithm with base e to the x. Ln of x is equal logarithm x to the base e. Now we have to know another things. Ln of x is the same as, because I said has inverse, is equal e to the y equal x. I mean here y equal ln of x. If ln of x equal y, ln of x equal y, this is mean e to the y equal x. We have some properties for ln of x. What is the properties? Any question for the natural logarithm? Anyone has a question for the natural logarithm or for the common logarithm? Any question for the graph too? So the common logarithm is the logarithm to the base 10. Natural logarithm is the logarithm to the base e. It's called ln. Is it clear? Okay, so what's the properties for the natural logarithm? So the properties of natural logarithm. First one is said ln of 1 is equal log of 1 to the base e, and this is equal what? Logarithm 1 is equal what? Always 0. Logarithm 1 for any base, always 0. Second one, ln of e. What is that equal? Is equal 1. How can I think for this one? Len of e is equal like logarithm of e to the base e, and by using the logarithm properties, this is equal 1. Here, len of 1 is equal log of 1, and by using the logarithm properties, this is equal 0. That's why here I can set len of 1 always 0. Why? Because this. Y1 because this. Third one, len of e to the x, this is equal x. Why? Because len of e to the x is equal logarithm e to the x to the base e, and by using the logarithm property, this is equal x. 4, e to the len of x, this is equal x. Why? By using the logarithm, this is equal e to log x to the base e, and this is equal x by using the property of logarithm. Okay? Any questions so far for these things? Okay, let me give you example. Last things in this section. So the example is find 1 len of e to the power 8, 2 len of 1 to the e to the power 2. Who will do the first one and who will do the second one? What is the answer for the first one? The answer for the first one is 8. That's true. Knowing Martin, this is true. Why? By using the property says len of e to the x is equal x. For this one, what is the answer? Angel, he said -2. This is true. Tell you why. Because len of 1 over e to the power 2 is exactly like len of e to the -2. And by using the properties here, len of e to the x equal x, len of e to the -2 is exactly -2. So the answer is -2. Any question? Anyone has a question? Okay, if there's no question, we're going to stop up to here today, and I see you next Thursday. And maybe next Thursday we have a quiz. I'm going to post anything on a Blackboard. Thank you.